Cooking? Okay, we're cooking. All right, so we want to run a couple of tests here. Oh yeah, so I even, because of you, also my terminal, I had all the things set up for the tabs, gone. Oh, you missed the whole thing where you had the stupid thing unplugged and I restarted my computer?
Oh, you restarted. Oh. I didn't realize you restarted your computer.
Yeah.
It's been like the first time in, what, 3 weeks?
What?
Longer than that, yeah.
Longer than that. Yeah, I don't restart. Okay, so let's see where we are right now. Okay, so we are 440 network client.
We won't need to reinforce.
Okay. Network client, network server. So I need to get the server. Just show me System Explorer. Pop the terminal up. I just have like a random Python file in there. All right, so let's just look inside my files here. Just get rid of clone stuff. Okay. Now I need to create a tab. Go into the client. Show in System Explorer. See this. CD. This. Okay, so this is server. This is share client. And this is get client. Okay, so what I want to do here is before we even run this, I want to go into our let's see, request thread and our client file fill thread, and let's have these guys give a little output, kind of showing that they're doing some requests and doing some fulfilling and all that jazz. Okay, so let's see here. This is when we're sending the byte that we want. So right before this is where we are trying to fill. So we're going to say system.out.println requesting byte I. And then we'll say waiting for response. Received response the byte. Okay, so now when our client is trying to get something, we should see the byte he's asking for, having him wait on the server, finally read something in from the server, this blocks right here, and then ultimately we should say what we received. So we're getting a little feedback here. And then over on the byte request side of things, Let's see, this is byte request. Waiting for a request. Received request for byte. Which byte? And then we'll say system.out.println byte request fulfilled request. Okay, and I'm going to go back into the file fill thread, and I want to put some descriptors in there so we kind of know where they're coming from. So this is file fill. File fill. File fill. All right, so for right now, let's just see if all we've done is added some output to the client side of things. Let's see if the clients are accurately dealing with stuff. Because I have a feeling it's the server that is blocking, and we need to multi-thread the server for these requests. But we will find out shortly. So here's the server, so we'll go ahead and star.java, even though we didn't change that at all, but I'll go ahead and recompile it. And then Java driver. That guy's waiting. Then we'll java star.java on the client. Java driver. I want to share. I'm going to share file 1. So this guy's waiting for a request, which makes sense because this is Tim's client, right? So you're not asking for anything. You're just waiting for somebody to come in because you already have all your stuff. Then we'll do Java driver, and we're going to be a get here. All right, so byte request, waiting for a request. Okay, nobody's requesting anything from him. File fill request, he's asked for byte 0. Now he's waiting. So who did he ask? He asked the server. Received request for byte 0, fulfilled request, waiting for request. Okay, so he did receive the request from the server for byte 0. He sent byte 0 to the server, but this guy never actually received that response from the server. Okay, so you got to go into the server code. So that's where we're breaking down here. We requested. Now we're waiting for the response. So that is right here. And this is our connected server, CS. So let's open up our server. Response thread. Here's getting mode. So forever, while true, we're going to read in which byte. We did that. So client made the request. We went and found a dude who had the request. We sent him the message. Actually, hold on. Oh, right here. So the client requests byte 0 in our example here. We request byte 0. Then we're going to go through and find another client who's not us, who has byte 0. We'll send that client. So in this case, who was our second client? Was it you?
No, Abe.
Abe. Oh, Abe. That's it. So Abe requested byte 0. We found Tim. We found that Tim had byte 0. So this is where Abe requested it. this is where. Are you taking notes or are you playing games?
Me? Taking notes.
Is he lying? What does he have in front of him?
I had my emails trying to find my notes.
Email. He does have his email open right now.
I'm trying to find my notes.
All right, because he was complaining earlier he didn't understand the stuff, and then he comes in here and wastes class time. I'm glad I let you fall into the lake yesterday.
Push me. Push me.
He had to push it. All right. After I caught my monster northern pike.
Yeah, I saw that.
No, okay, no.
No, it only looked. Yeah, it actually was before.
It was
Before,
like a
after I
small
caught
northern
mine.
pike.
You know, the thing is, that thing was about 7 feet long and about 40 pounds, but
Nice-
it didn't look.
nice
It didn't
plane.
look like that because I'm so large. So anything in a picture next to me looks
All
tiny.
about that
That's
angle.
also the reason you have to know when you're on a boat.
Well, no, here was the issue. So he caught a fish too, and on the lure he caught the fish on, which is now his lucky lure, which kind of makes sense because I also caught my fish on that same lure after he fell in the lake and left. But he got it caught on a branch that was about 4 or 5 feet out into the water. Well, so he didn't want to lose this lure, so he wanted me to hold his hand so he could kind of get dipped in.
I should have seen that going bad.
And I would recommend not, so I just kind of stepped down into a little bit of, it wasn't like soaked mud, but kind of a little bit of wet mud. I wouldn't recommend doing that in dress shoes. They have no grip. So everything was going fine until he decided to take that one last little lunge. So he was probably at about, I don't know, let's say a 77-degree angle. And he decided, let's take this to 80, but quick. And my right foot just slid around, so I slide into the lake.
Nice.
only up to my calves, like really. And my butt's sitting on the shore, and I'm just laughing. Okay, he face plants into the lake.
I went completely underwater.
But now I don't feel bad because of this crap. All right. In any case, focus.
I was wearing dress shoes. They look good.
Yeah, they were these shoes. I cleaned them.
Mine are still a little wet.
All right, shut up. I don't like you. All right. Abe requests byte 0. The server goes through and finds a dude with byte 0. We've discovered that Tim has byte 0, so we sent that message to Tim. Tim has received that message, so here's received a request for byte 0. Tim fulfilled that request. So that means right here, this is the line that's not happening. cc.readByte should be coming in from, okay, so we sent it to Tim. Tim then responded, so this should be the byte that Tim sent back. We might want to just separate these into multiple lines. Let's say int the byte is equal to, because we know this is where the breakdown is. System.out.println response thread waiting for fulfillment. Then we'll read it in response thread byte received the byte, and then we're going to send the byte to the client. Sending to requesting client. Done sending. And then found byte is equal to true, which means that when we exit out of here, wait a minute. Shouldn't I be breaking out of this loop? Why wasn't I breaking out this loop? Was this loop an infinite loop?
There's no horrible.
Yeah, for each. You're going through all the not busy clients.
So actually, this probably wasn't the problem, but I can break out of the loop. So this probably wasn't breaking anything. I was just being inefficient. But I can get out of the loop now since I've fulfilled the request in theory. And then if it was not found, then we're going to just send. So actually, let's put that out there. Response thread. No.
404 byte not found.
404. I like that. 404 byte not found. Response thread sent -1 byte. Okay, so we're just putting in some commentary here so we can kind of see where things are getting communicated. My feeling is that up here, this line right here where we're reading something in from CC, we need this to be threaded. Because CC is one of my connected clients, and that connected client might also be now having communication with the server on his own thread. So we might need to have this thing happen inside of a thread. So we'll see where it gets stuck up in here. So we need to kill off our server, which then should kill off all the other guys. So these should all be disconnected now. Oh my god! Now they're disconnected.
Well,
Let's recompile. Waiting for the server. Recompile. We're the sharer. We're sharing that file. Byte request, waiting for a request. Okay. Start it. We're the
requesting byte.
Okay, so byte request, waiting for request. File fill, requesting byte 0. File fill, waiting. This guy waiting for a request, received request, fulfilled request, waiting for a request. So the last thing we had over here was file fill, requesting byte, file fill, waiting. That should be right in here. So we get to this line right there. This guy's blocking. So this isn't actually happening because I think CS is busy doing something.
What's going on in the server?
What's going on in the server? Oh. Yeah. Server, waiting for fulfillment.
Byte received 255.
Sending request to client. Oh, then done sending. That came from the response thread, so it got here. Do we need to flush this dot the client dot send byte. So this the client dot get. What's the client? Oh, that's our connected client. I wonder if we need to flush the socket. Let's go in here to connected client. After we send a byte, we write it there. Then we're going to say this dot the socket dot get output stream dot flush. Let's see if that's the problem. If the getting client couldn't read from it because the server tried to send it over the client but didn't flush the socket, allowing it to actually flow to the client. Be nice if that's the entire problem. So we'll disconnect, 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 recompile, run, recompile, run, share, 1. Done sending. That guy's, so it's the get client. File fill waiting. No, still stuck. We're right here, but not getting to here. And this is in our file fill thread. It's our connected server. Let's look at connected server read byte. Let's make sure we're in here. Trying to read byte. Let's make sure that we're actually able to get into.
I think you wanna
You should stop it from throwing the exception.
put a flush in the center.
Oh, I can't do this anyways. Trying to read byte. Yeah, you want to do a try catch in here?
Yeah.
Actually, before we do that, let's make sure that we are getting into the method. So it's possible that if it's blocking because of the multi-threading issue, that means that right here, file fill request, when we call cs.readByte, I'm wondering, are we even successfully calling this method? If we're not successfully calling this method, that means that the thread that CS is involved with is currently busy. So he's being blocked, so we can't even call the method. If we're getting into the method, so if I get to this line, that means that there's probably an exception. We should go ahead and print it out. So let's see how far we get. This is actually good because we get to understand some of the issues with threading and blocking. We're going to share. There's clone. We're going to get. Okay, trying to read byte. We are getting in there, so let's go ahead and look at the exception then. So we will try to do this. Catch exception E.
You should just do print stack trace.
Yep, you can. I think that just calls the toString method. And then, well, here we can just return -1. Okay, so let's see what this guy looks like. So this would be on the client side for the connected server. Share that. Get that. Trying to read byte. Okay. So no exception, which means that we are literally blocked. Where's my try catch? This line right here. This line's blocking. So we are trying to read from the socket successfully. And who wrote to that socket? This is the connected server. So the person who wrote to that socket is our server over here, response thread. This is when he sent the byte. And is the server saying done sending? He is.
Look at the send byte method.
That's in connected client.
Client object.
Yeah, we flush. That's what we already did.
So you do flush it. Okay.
Should we double flush? Sometimes you gotta flush twice. There's actually some truth to that.
Courtesy flush.
I would say there's maybe a 20% chance this will fix it. That's why we have so many different ways of writing buffered things to sockets. All right. It requires a courtesy flush. We're going to share that. Run that. We're going to get. Still trying to read byte, waiting for request, done sending. All right, so the disconnect is between this guy connected client after second flush. Oh, hello. To write byte. So let's make sure we're getting into this method inside of our server. Doesn't this feel like we're on a quest? So much fun. So that we're going to share that file. That we're going to get. All right, server. Trying to write the byte after the second flush, so the server successfully sends the byte, flushes twice. Are we sending it to the right person?
No. What's happening if you have two threads trying to, one of the threads request for the read byte so it blocks, and the other threads send something? You get what I see?
Yeah, so
Because you have two threads running for the same connected client. Because one is the fuel thread and the other one is the
byte request.
Yeah.
Both of them don't have different sockets.
no, it's just one socket.
Yeah.
right. So do we need to thread the socket connection?
Yeah, what if your byte request thread is stealing the messages meant for your file thread?
You might try not, just for testing purposes, not starting the byte request thread for the file when you are getting.
All right, so not starting the thread that we get from him, our sharer.
Yes.
No, not starting
Because if you start a
on
Git client,
the,
it's
per-
also
the
gonna
Git
start
client.
Let's
don't
draw a
start
picture.
Don't start the byte request thread for the Git client.
Don't start a byte request thread for a
Because you have
Git
two
client.
clients going, both of them have both of those threads going.
Yeah.
So
So there's
That's
two
the-
separate threads, two instances of that thread.
yeah. So I don't know if you'll do this just through some input and then if statement or something, but don't start the byte request thread, the one that would be,
When Abe connects.
yes, when Abe connects.
Well, not the byte request thread.
Yeah, don't start that one.
We're on the server side. Do you mean on the client side?
On the client side, on the Git client.
Oh. I get what you're saying. You want to test this. We're going to assume that Abe is never going to share bytes.
Yes.
Correct.
Okay, I get what you're saying. So we're going to go back to the,
So that's the issue I ran into. Is on my Git client, my threads were stealing each other's messages.
okay. So on the client communication protocol, if we are a share guy, we're only starting the byte request thread. If we're a get guy, we're only going to start the file fill thread.
Right.
That's what you want to do, right?
Yeah.
Okay. So kind of defeats the purpose, but let's see if this fixes the communication. See, if this is the case, that's actually going to be a really interesting problem for how to make this thread safe. Okay, there's that. We're going to share file 1. We're going to get, oh. So done.
I think you might need 2 socket connections for serving this file, for sharing and getting it. Or you have to synchronize some way.
For the sockets.
Yeah. For the reading and writing bytes.
We can actually do that. But can we preserve the order? Well, in the end, I think we should have gotten our file, right? If I do my files, there's our clone, and I don't think we had that before.
It's Bob.
Oh, Bob. Right. Yeah, we definitely didn't have that before. So now we do have Bob. So we did send it. We had the communication going back and forth, so that's working. But now we need to have this guy being able to do both.
Can you open Bob?
I'm sure we can. I don't think that's going to be. I don't think that's an issue.
I'm curious to see if the
Your chicken did.
if it got messed up. And
This is the.
it's like Nightmare Bob.
Where's my refresh?
Refresh F5.
There you go. Is it like Nightworm? Oh. Heavy damage. Hold on. Wait a minute. Was this from the second flush? Actually, you know what? Let me take the flushes out.
Yeah, no more courtesy flush.
No more flushing,
Just
period.
leave it there.
Flushing is overrated.
Double flush.
It's yellow light.
Plug for it.
God made it smell that way for a reason. Christian worldview. Okay. So I need to go here. So I go here. Okay. Go back one level. Well, I had killed off the server.
Yeah.
All right, so there's that. Now we're going to share it again. And we're sharing that guy. And now we're going to Okay. How do I get a detailed listing? That's not important. Let's see, present working directory.
View it in Finder. I want to see how many bytes it is.
Yeah, that's what I wanted to. I was trying to do that, the command line. Where is this? This is in Alphabet Workspaces, Eclipse Workspace. Okay.
Understand now.
See, it's in
My files.
My file's right there. Today at 3:54 p.m.
46 kilobytes, 46 kilobytes. Man, look at this. This guy, it's like we have the secret byte isn't getting written.
Open the as a
Open what?
open to see the byte itself. I had a similar problem to see where is different, like the text detail.
I'll like compare the two documents.
Well, that's not going to give us. We need to be able to do a byte reader. Let's actually look where it's writing.
Try to send a text file so we can compare the text.
Yeah, that's a decent idea. But we're still sending it in bytes. Okay, so we'll come back out here. We're going to remove bob.jpg. And then let's do vi file1.txt. This is just a test. So that's file 1 we're going to try to send. And it'll ultimately get saved as bob.jpg. Okay. Kill this.
Plot twist. Opens up.
Oh. That's fine. So we're sharing, and we're doing file 1, which is 2. And we are all right, 10 bytes. Bob.jpg, open with. This is just a test. It's got to be where we're writing. So it sent that
Read
correctly.
the output of the file fill thread. Get client in the terminal.
Oh,
There's not that
This
many
is-
bytes.
oh, I see what you're saying. Well, there's,
Requesting byte 0. And read response 116. What's it printing off? Okay, that's what the byte is. Okay.
but you're going to have carriage return bytes and end of file bytes, and
Yeah.
let's look at how we're writing it out to disk in the end. So this is fill file. So at the end, That's very interesting. So we have it cloning now. I think we'll definitely have to multi-thread the thread. But why is the clone not quite like the original? Okay.
Yeah.
All right. So we're going to start off on Friday trying to figure out why our clone is not the same as the original. I'm guessing we're short 1 byte. So what we're going to need to do is we're going to have to display both byte arrays and compare them and try to check on a byte by byte basis that they're identical. This worked, but my feeling is that since it's a text file, this last end of line thing here, for a binary file like a JPEG, it was corrupt. For a text file, the text editor knew how to ignore end of file. All right, so I think it's that last little piece that we're not writing correctly.
Does Photoshop know how to open up a corrupt JPEG?
I don't think